Okay, good morning and happy Monday. I'm planning on doing LeetCode contest 303 virtually. This is the contest from last Saturday. So here we go. Okay, open these guys up. Time to shine. First letter to appear twice. All right, just use a set of scene. Let's see. Scene equals set for C and S. If C and scene, turn C. Scene dot add C. So make sure it's slow. Okay, should be good enough, right? Yay. Okay. Okay, same row and same column. There's one equal row and column pair. Row 2, column 1. Row 2, column 1. Okay, yeah, that makes sense. Okay, so let's join them to a string and then compare them, right? All the rows and all the columns. Rows, columns. Or should we, yeah, we should have rows and columns and we'll compare them all. And that works. Okay, so for for each row in A, I wonder if we can transpose the matrix. I think we can. But anyhow, let's see. A row in A. Rows dot append join row. Hold on, let's see. I think we can do this to turn the rows into columns, right? Transpose it. Let's see. Uh-oh. Row dot append find int. X for X in row. And print A. That, so transpose it. 3, 2, 1. No, it does not transpose the matrix. Python 3 transpose matrix. JI. Okay, I guess that works. Let me close this. Let's do this. Fine. Okay, that's okay. A 0. Or are they the same? Yeah, they're in by n. In by n grid. Okay, so hold on. let's do this the long way and then we'll optimize it later. Have a high and range in, oops, or J and range in. Ninth row in the jth column. I guess we can go through all J columns. I mean, it's just fine. The rows are simple, right? Okay, so rows equals join. Sure. Come on. Correction row for row in A. Okay, and then each of these column equals this. Full append. E sub I sub J. Rows and columns. Columns dot append. Join x for x. Stir and column. There's kind of just cool. Count to the end. Okay, something like that, right? Should be 1 for this guy and then 3 for the other guy. Sure, it's taking a while. Okay, looks good. La, da, 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 da. Okay. Okay, food cuisines and ratings. Highest rated cuisine. Okay, so there's cuisine is the category of food. So of all the foods in that category, what is the highest rated one? Okay, so category will be a bucket. All right, so use a map to store all cuisines. Is a bucket of cuisines, right? Bucket of cuisines. List of foods. Ratings. Sorted list. Okay, let's do this actually in C++. Using map. Actually, let's do this. Just call bucket. Map cuisine and then a list of foods per cuisine. It should be ordered in a set. Let's do this. Struct food name rating. A name and a rating for each food. Food. Okay, so that's that. And then using foods as a vector of food. Okay, so a bucket has a vector of food. It needs to be sorted, so it needs to be a set. Sorted set. And that sorted set needs a custom comparator. All right, we want to sort it by rating and lexicographical order of the food if there's a pair or a tie. All right, so C equals one set. So I want to look at the comparator or the constructor that we can pass in a comparator for custom comparator. Compare. Okay. Actually, let's see, it'd be struct comparison rater size t. Oops, hold on. So reference of food comparing A and B. Turn A dot rating equals B dot rating. Then lexicographical comparison. A dot name is less than B dot name. Otherwise, B dot rating is an A dot rating, so it's decreasing order. Set food. So I'm going to call the constructor set. Hold on, I haven't done this in a while, but we want comparison, right? Comp class. Ooh, oh, that's a Boolean? Oh, okay. All right, well, all right, fine. Ooh, okay, that does make sense. So those are our foods that are ordered by rating in lexicographical order in case of a tie. Okay, so our bucket is cuisine, right? Cuisine, foods, ordered set of foods. For a string, vector of integers. Foods, cuisines, ratings, food, rating, cuisine. Okay, so buckets of foods, buckets, so foods dot size. Auto I 0 is less than n. So go through all of these guys here. Okay, so bucket. Okay, so auto food equal food sub I. Be nice if we could zip these things together. There's no zip in C++ that I know of, though. Cuisine equals cuisine sub I, then rating equals ratings sub I. Buckets of cuisine. Insert replace food rating. Okay, so change rating. So we need to find out what kind of cuisine the food belongs to as well. Cuisine for the food unload map. String. So we know the bucket. Cuisine. Cuisine. Oops, okay, so that doesn't work. Made it called a type. Food type. Oh, type of cuisine. Is that okay? It's a reverse map from food to types to category. Change. Right. Okay. That should be fine. So type of this food is cuisine. Okay, so cuisine is type of food. So cuisine, race, food. Okay, so cuisine. Insert replace food with rating. All right, highest rating cuisine. So return it's a cuisine and second. Something like that. Okay, let's see what happens here. I'm looking for, oh my goodness, kimchi ramen, no sushi ramen. Struct, oops, should be lowercase. Where's the specifier? Oops, yeah, I put the ampersand in the wrong spot. Thought that looked funny when I was writing it. Okay. Constant reference, okay. Foods of I. Oh, oops, okay. Foods and cuisines is a string, whereas ratings is an integer. Uh-oh, no matching function call to erase. To set food. Sorted by rating. Oh, okay, so cuisine can it does not equal bucket, so cuisine dot end. Okay, so this will be a linear scan to find and delete this food. Are we sorted by rating? It's a map there, isn't it? I mean, we should be able to look it up. Right, it's a set of food. It equals set of foods. Wait, hold on. Name food. It should be. Yeah, okay, let's just do this. Fine, whatever. It equals this guy. Oh, it's a cuisine and it's name is not equal to food. So it's okay. A little bit inefficient. That is linear. Second, oops. Cuisine again. It's not second, but it's rating. Big money, no whammies. Uh-oh. Can no viable conversion constant to it's the name of it? Okay. Name with the highest rating. Okay. Yeah, so it's sorted in descending order by rating or bucket of cuisine. Okay, kimchi ramen, no sushi, no ramen. Okay, that looks right. Big money, no whammies. Uh-oh. Oh, dang. Okay, so that was a linear scan. Dang. Holy cow, Zoli. I think it's huge. Let's see. What are the asymptotic bounds here? All right, we can't. 20,000 calls will be made to change rating highest rated. Okay, so 20,000 is too much. Okay, so bottleneck. Uh, TLE is here. Linear scan. food. Okay, so how can we make this a little bit faster? Let's do this. Change rating. So rating of a food. Can we find food faster? So to find the food faster, we have to store the food by name. So we can do maybe O1 lookups to update. It seems like we would need a priority queue, but then how do you update the rating? Hmm. So we're continually extracting the maximum. So definitely a priority queue or a heap mean seems to make sense, right? Or an ordered set, either way. Logarithmic indels. I thought it would be logarithmic indels, though it's not, right? Not able to find food fast enough. The food to delete. I wonder if we insert it, could we keep a track of the iterator itself to change? Set in place, does that return the iterator? Excuse me. In place. Yes, it does return an iterator. Oops, hold on. Okay, so in place returns an iterator. It doesn't matter. It's going to be true for the Boolean. Okay, so that is the food. So on an iterator of a pair, pair equals iterator of this set using iter equals iterator of this guy, pair of iterator and a rating. Using what do we want to call this thing? It's the food itself. The food's rating. We want the food to iterator, right? Food string iter. All right, so food name to set iterator to update the rating in O of 1 time. Using rating on our map. String to iter. Pair. I'm not sure if we need that then. All right, this is food name set iterator. All right, this is good enough. Okay, so there's our rating. Okay, so rating. So food equals it. Okay, and then say it equals ratings of food. Delete it and place it with something else, right? Okay. Okay, still running. Uh-oh. Type int does not provide a subscript operator. Rating. What? Food. What? Oh, rating is used here already. Okay, so we're gonna call this thing food it. Food iter. It's fine, right? Whatever. Food iter. Food iter. Just call it iter, right? Iter's fine. Iter sub food equals it. It equals iter sub food, and we'll delete it. Replace it. So O of 1 time to delete it, or no, O of n time, login, like log in the operation should not TLA, right? Should be okay. I think so. Come on. Let's go LeetCode. Okay, that looks good. This one hopefully does not TLE. Huge. I guess hoping is not a proper strategy, but we'll just have a love of fate and see what happens, since the obstacle is the way. Failure can teach us a lot. Runtime error. Oh dang. Okay, so this is not cool. I think maybe the iterator changes as we insert other things, right? So this might not work. Ugh. Yeah, we can't erase it then, right? We have to actually modify it, right? Iterator is the object and location of that thing. So instead of erasing it, can we just change it? It's rating. It's rating. I don't know if that works or not. Holy cow, this thing's huge. It's separating, cannot assign or return by some because the operator returns a const. Separating it is a constant iterator, isn't it? Oh man, okay. Yeah, this one is tricky. Tricky to avoid TLA. Right now I'm putting stuff on the wall to see what sticks. Which is usually a good time to take a break and come back. How would I store this thing so it doesn't TLA? Right then, that's a question, right? Right. The basic question is which data structures to use to avoid TLA, since linear scan of foods per bucket cuisine to update the rating results in TLA. Okay, whatever. I got a lot of room for improvement. And let's see how much time we have left for Q4. I have 53 minutes left for Q4. Okay, so here, do this. Lead on Q3. There's 53 minutes remaining. Q4. Okay. A pair of numbers is called excellent. They both exist. The sum of the set bits is greater than or equal to k. Or and. Distinct excellent pairs. Two pairs A, B, C, D are considered distinct. A does not equal C and B doesn't equal D. 3 and 3 and 3 or 3. Num's length is 185. K's less than equals 60. Or is the bitwise or operation and is a bitwise and. Okay, so this one. Why is case 60 there? Up to 60. Shouldn't it be at most 9? Oh, wait. 30, 32, isn't it? Each number itself is less than a billion, less or equal to a billion. So you'd think anything over 30 would not work. So number bit set. Okay. Take the set of scene values. Pair each value x to itself and all other y on x values. Where this is less than y. Pair only half of each pair. Right, so if it's okay in one direction, it's okay in the other. So it'd be 2 times that as long as they're not equal. Okay. Okie Scene is a set. The list A. Okay, so this is quadratic. It should TLA, but start with TLA. Start with TLA. Right. Working root. TLA solution, then optimize it. See, right, that's the game plan. It's okay, it can be a function, right? Okay, x, y. The amount of bits can be the binary representation of each item, right? So bits equals, let's do this. F x in x. Let's do this here real quick. Python 3. No, I think I have Python 3, isn't it? This thing's so slow. Oh, okay. X equals 10. It's a binary representation of x is this guy. Binary representation of x. Skip the first 2. Oops, hold on. Skip the first 2. It's this guy. Then we want to add all the ones. The length of character for character in that string, if character equals 1, cool, something like that. Okay, let's do this. That, okay, so bits equals f sub x plus x or y plus f sub x and y. Okay, so if bits is less than or greater than or equal to k, right? Or not. It exceeds k is equal to k. Okay, if okay, x, y, if x equals y, okay, so count x equals y if that, else true if they're not equal. Okay, hold on. If x is less than y and they're okay, turn the count. Okay, something like that. The brute force, we're looking for 5 pairs. Go, LeetCode, go. Uh-oh. Look over account reference before assignment. Yeah, that's right. Uh-oh, I only got 4. What? Oops, s less than or equal to y. Okay, so I wasn't getting the 3s. I was missing. X equals y. Okay, that should be okay, and that should TLE, I think. Really slow. Okay, that's 5. And then 0. 5 and 0, and then I'll submit this. It should TLE, and that's a good start for a brute force solution to optimize, right? Go, LeetCode, go. Okay, TLE. Okay, so it does seem like a correct solution. It's just taking too long since it's quadratic. Okay, so quadratic and time of n squared results in TLE as expected. As question now, how to optimize this solution for AC, right? This is actually bottleneck crux of Q4. So how do we improve this? Right, we need a near linear solution. What's been seen previously compared to current? May sort it to a scan. Maybe only consider certain candidates. I don't know. Yeah, I'm not sure. So we could pre-process the input. This is the input, sorting. It's going to filter candidates bucket or something. Hmm. Bits exceed K. I don't know. I'm not seeing it. How do you do a linear solution, a near linear solution here. Can I look it up in binary search? How could he? It's kind of like two sum. Yeah, I don't know. I'm trying to blank. Yeah, let's go back and do these ones here real quick. Return non-existent character. It's fine, right? Some signal value. Sentinel. Okay, whatever. Let's just go do these here real quick and let my subconscious work on it. I'll probably have to use pen and paper and write it down, which is like super boring. I'll do that here while everyone's watching. Oops. Hold on. This guy's cool, right? 3. Script, Kotlin. Right, perform linear scan of each character. C of the input string S to track scene values. Right, that's cool. Good enough, nothing too fancy. On our set row of 1 lookups. Set of scene. For each character an S if at scene dot insert C dot second. Turn the character. Turn. Stars our sentinel value. Sentinel. It's cool. All right. Use SCD collections, set, mute, scene, well, let's cache set, new, CNS.charge, turn sky, base sentinel. If scene.contains, C, turn C. Otherwise, scene dot add C. Good. Uh-oh. Not dereference it. So, uh-oh. Oh, it should be insert, right? Cannot dereference it. Oh, okay. So we don't have to borrow it then? I was borrowing it. Okay, it's cool. Rest, JavaScript, string, scene is a new set. Except for, let's see, S, split, character, and then setting value. If scene dot is a character, return character, otherwise scene dot add character. It's good. It's cool. Okay, let's do Kotlin. Characters for C and S. If not seen, that is the character. C, otherwise, C and the character. Signal value. Okay. Okay, yeah, nothing too fancy, right? There's our signal value, set of scene. And ordered set for one lookups. Enough. Could be. Yeah, these ones are kind of really naive. The ones that I solved, right? And it's not algorithmically complex at all. Okay, so convert each row column into a comma separated list. Oops, comparison. Python 3. All right. Rows and columns. Jth column. Row. This column. Something like that. 1 and 3. Okay, looks good. Nothing too fancy. Okay, JavaScript. Rows, columns. And row. Okay, something like that. Uh-oh, that's no good. Oops. Rows and columns. What's going on here? Uh-oh, too many commas. What is going on here? Oops. Too many commas. Cool. Okay. 1 and 3 is cool. Okay, do Kotlin. Okay, it looks good. First. I don't think that join works. So yeah, I'll have to fix that. Okay, I need to collect those. I put them into iterator and then collect them as a vector of characters. And create. Fix the compilation. Let's go LeetCode. Sure, it's taking a while here. Unable to pre-process compiler. What? Holy cow, I really broke it. Okay. 20 minutes left. Yeah. Back. Okay, too much garbage. Oh, well, I don't know if I want to do this in a restaurant or not. Just seeing this. Let's see. Let's do this. Does that work at least? Yeah, so I gotta do iter.collect. If you can join it or not. The slice isn't found, right? Let's see how we do this. Rust to how a separated string. Turn it into strings and then flip. That looks great. Okay. Map x dot to string. Oops, hold on. This collect to vector and then join it. Strings that can be joined. Vector string. String collect into vector strings constructed value. Row.iter.map. Oh, okay. Fine. That thing. Right. And through. Okay, that looks good. Okie dokie. Right. There's this guy. Oh, dot iter. Map. Try x in the column to x2 string. Select it as a vector of strings. Join it. Separate list. Push that there. For them. Over here at remove. Just borrow the row. Oh, don't want to borrow it. Borrow each value x, right? Pretty sure you want to borrow it in the object location of that to string. Doesn't have a same kind of compile time. Doesn't implement the copy trait. Borrow a. Borrow rows, borrow columns. 1:30. Okay, so that's cool. Get there eventually. All right. It's good enough. Not to be perfect. Good enough, good enough. This one I still need to work on. 12 minutes left. Okay, I'm gonna call it a day, I think. Come back to this one. Come back to this one too, the book TL lead. And just sit down and just take some extra time and then try to rush through it. Oops, yeah. Catch you next time.